Welcome to the Salmon Runs YouTube. Enjoy the video.
You start by writing the rational function as a fraction p, x over qx and simplifying. Explain why. Simplification reveals removable holes and reduces algebra later. Next, you find the domain by solving qx not equal to 0 because excluded x values determine vertical asymptotes or holes. When a factor cancels, you get a hole rather than an asymptote. Once done, factor both numerator and denominator fully, since those roots drive intercepts and discontinuities you will plot. Now determine asymptotes and intercepts so you can sketch behavior. For vertical asymptotes, mark x values where uncancelled qx equals 0 and analyze signs near them to see if the curve blows up positive or negative. For horizontal or slant asymptotes, compare degrees. Equal degrees give a horizontal at leading coefficient ratio. Degree numerator 1 larger gives a slant by polynomial division. Also compute x-intercepts from numerator roots, not cancelled, and the y-intercept f is 0. Finish by sketching segments with the asymptotes and points as anchors. Start near leftmost behavior and move right, testing sample x values in each interval between vertical asymptotes and holes so you know whether the graph is above or below the axis. This step explains why the curve connects the points the way it does. Once the rough sketch aligns with intercepts and asymptotic behavior, refine slopes to approach asymptotes smoothly and add a troubleshooting check. If a segment looks wrong, re-evaluate cancelled factors and sign tests.
Thanks for watching. Consider subscribing if we helped you.